Alright, I'm back. The two ways of liberating gases is reacting hydrogen ion with carbonate ion to make carbon dioxide and H2O. This is what's happening inside soda. Or to react hydroxide ion with ammonium ion to make ammonia and water. Okay, this is what happens in asparagus P. Yay! Alright, so in this case you have the hydrogen ion because you have hydrochloric acid, and the only thing that has CO3 2- is right there. They actually gave it to you. They might give you those names, but in this case the answer is D. When hydrogen is burned in air, so that's going to be H2 plus O2, which reactant behaves as the oxidizing agent? So they want to know who is reduced. So I made my predictions. You have two neutral atoms, so you're going to do up, down. This is going to go to H plus, that's going to go to 2-. I can stop there. The person that was reduced was the oxygen. So there's my answer. Each of the following compounds was added to distilled water, H2O. Which one produced a pH greater than 7? That means which one produced OH minus. Okay, so basically if water was added to each of these, which one produces OH minus? So whenever you have plus H2O, that is a keyword. Flip it over to the back side of the chart and look for all the water reactions, and the only one that's present that resembles anything here is D. Okay? Nitrogen plus water is not present, oxygen plus water is not present, a metal with iodine is not present, but metals with oxides are present. Carbon dioxide is not a metal. This would produce Mg2 plus 2 OH minus, and it would also take phenolphthalein from clear to pink. The more things you write down before you start the problem, the better. When fluorine gas, F20, is bubbled to a concentrated solution of potassium chloride at room temperature, which of the following would be expected to occur? So before you do this reaction, let's just do it before you answer the questions. Okay? So you see ions, you see one neutral atom, so we're going to do redox. That's going to go down to minus. Cl is going to go up to 0. And it's a Twinkie. Potassium is my spectator ion. Okay, so in this reaction, fluorine was reduced. It's the oxidizing agent. Chlorine was oxidized, so it's the reducing agent. Let's go through it. All right, so chlorine gas will be produced. Chlorine is produced. We're not sure if it's a gas yet, so we're going to circle that and come back to it. Potassium fluoride will precipitate. This is not a precipitation reaction. That would be two smiley faces. Get rid of B. Sodium chlorine will precipitate. First off, that should say sodium chloride, so we know it's wrong, but, oh, that's a solid sodium, I bet. Chlorine is not a solid, it's a gas at room temperature. But precipitation is not going to be any of the choices because this is a single replacement reaction. No reaction will occur, a reaction will occur, that will never be a choice on the AP test. So chlorine is produced and it is a gas. You don't have to memorize that, but on the periodic table, reds are gases, blues are liquids, and black equals solids. Okay. When magnesium ribbon, Mg, reacts with dilute silver nitrate, okay, which reactant behaves as the reducing agent? So who is oxidized? Okay, so we have a neutral atom and we have ions, so we're going to do our up-down. Magnesium, according to the periodic table, because it's an alkaline earth metal, will go up to 2+. Ag is going to go down to 0. NO3 is my spectator. Mg goes up to 2+ plus Ag. So I'm looking for who is oxidized. That would be Mg, because it went up. So the answer is C. It said which reactant. So Mg, Ag plus, and NO3 minus are my reactants there. This said a student added a soluble ionic compound to an aqueous solution. So some compound, A plus and B minus, that's soluble, so I see my ions, was added to a solution of sodium sulfite. After the compound was added, a sulfate compound was observed as a precipitate. So we got some compound that contains sulfate. Which of the following could have been added? So in 1, would Ba2 plus and SO4 make a precipitate? Yes, they would. So 1 could be a choice. In 2, would Pb2 plus with SO4, 2 minus make a precipitate? Yes, they could. I'm getting these from the chart, the solubility chart. Okay. With 3, could Ag plus and SO4, 2 minus make a precipitate? Yes, they could, but that is not the choice because this is already insoluble. And they said it must be soluble initially. So 1 and 2 are our choices. This is a tricky problem. If you can do 14, you are good with solubility. All of the following are true of alkali metals except. So let's write down some things about alkali metals. We know they react violently with H2O. We know they form +1 ions. Okay. So they are strong oxidizing agents. Oxidizing agents are reduced. We know that alkali metals go from 0 to +1. That equals oxidation. Alkali metals are not reduced, they're always oxidized. So A cannot be the right answer, but let's double check everybody else. They form +1 ions, that's true. They react violently with water, that's true. They react to form basic solutions, they do. When they react with water, they form OH minus, check your chart. They tend to shed 1 electron to achieve a noble gas configuration. All that means is all the alkali metals lose 1 electron always to form their +1 charge. So that's also true. The answer is A. When the reaction goes down, they're basically asking you to balance it and what's going to go in front here. So when you have a reaction with H2O in it and OH is flying around everywhere, rewrite it as HOH, and it's easier to look at. 2 B's, so we put a 2 here, 1 C, 1 C, 1 H, 4 H's, so we're going to put a 4 here, 4 OH's, now we have 4 H's, so it's balanced. The coefficient is 4. Next one. We did this one, that's a repeat, but the answer is A. Alright, so we got this weird sentence. We're talking about delta H and delta S. We know that delta H can be negative or positive. We know that delta S can be negative or positive. We know that this would be release heat. We know this would be absorb. We know this would means it gets hot. We know this means it gets cold. Negative means it gets clean, messy. Clean is going to be going from gases to solids, and messy is going to be going from solids to gases. All right. A white solid compound is added to a beaker of water. The compound dissolves in the water. So we're going away from, messy. This is reversed. Solids, gases, clean would be gases to solids. So we know it's going away from solids. It's dissolving in the water, so it's getting messy. So we know that delta S must be positive. So we can get rid of A and we can get rid of C. Alright. And the measured temperature increases, so it gets hot, it releases heat. So we know that delta H has to be negative. So that's going to be B as our choice. Or move on. Okay. Which of the following are the correct products produced when potassium metal is dropped in water? So K0 plus H2O. I wrote my reactants. I do not see ions. I do not see 2 neutral atoms. So I'm going to go to my keyword, which is water. I flip it over to the other side, and I see that I'm going to get something that looks like this, and I'm going to go search for that, and there it is. Number 20, which of the following would use bromothymol blue be appropriate? So B blue turns from blue to yellow in the presence of what? You got it, carbon dioxide. So I'm looking for the reaction that produces carbon dioxide. I know that I get that when I take something with H plus or acids and I react it with something that has CO3 2 minus, which is carbonates. So I'm looking for the word acid and carbonate. I do not see them here. I see acid here, but I do not see carbonate. I see carbonate there, and I see acid here. So there's my solution. See you guys next.